The key component of this project is the advanced application of the satellite remote sensing data that can provide the efficient, cost-effective and the robust monitoring of tailing storage facility. According to the ICMM, which is the International Council of Mining and Metallurgy, according to that, the tailing storage facility must have an independent review, and our system is providing the independent assessment to have the reliable and transparency between the stakeholders, mine management and the engineers. This system is basically is used for the management and monitoring of tailing storage facility, and it also complements the ESG issues, the environmental, social and the governance issues. In addition to that, the GIS and remote sensing based tailing spill path model has been developed for the predictive modeling of tailings flow path in case of tailings failure. And that model has been applied on the Brumadinho Dam, and it was validated on the Smärko Mariana Dam, and it provides the accurate prediction. The results that was provided by the model is exactly aligned with the tailings flow path that was occur in the failure of the Smärko Dam. So almost 95% accuracy was achieved by the model. We can get the data almost on after 10 days to have it will generate the automated maps to say that the deformation is occur in this area with this magnitude, and it is moving with this velocity over the period of time. So so once you have identified the critical hotspots, then you can have the detailed field survey, or you can use the drone technologies to get the detailed insights of that critical areas. We have used the satellite technologies to monitor the environmental parameters and the geochemical parameters. For example, the concentration of the different gases like carbon monoxide, carbon dioxide, methane, NO3 and these kind of gases, and also what is the different water quality parameters like the sedimentation, silting and the acid mine drainage. So in our project we have used the data from the multiple satellites, like the MODIS products has been used for the environmental and the geochemical monitoring, and for example the temperature, precipitation, humidity, speed, wind speed, wind direction and evapotranspiration was extracted from the MODIS data using the different algorithms, and also the biodiversity, the geochemical characteristic was extracted from the Landsat 8 and the Sentinel-2 data, and the INSAR data processing was done through the Sentinel-1 data, which was used to monitor, map and detect the deformation inside and around the tailing storage facility. We have used artificial neural network algorithm to develop the tailings flow path model, and we have used the machine learning algorithms to convert the remote sensing data and the geospatial sensor data to convert that into a meaningful information, to find the hidden patterns inside the data and to find the behavior of the tailing storage facility. And along with that we have developed the geoportals, and we have used the Python programming language using the Anaconda environment to fully automate the system for the monitoring of and mapping of the tailing storage facility. And we have developed the geoportal that that is based on the mining analytics and the space-time pattern mining and the space-time cube algorithms to get detailed insights of the temporal data. Basically, the space-time cube incorporate the data from the multiple sensors and in multi-dimension with in terms of time and the different attributes. So we can use the multi-dimensional and the multi-attribute data to find the hidden patterns in terms of trend, in terms of the behavior of a specific feature. We can use the huge amount of data, as we know that the remote sensing data is big data, and the data we are getting from the geospatial sensors that are installed on site, it is also high frequency and it is also big data. So space-time pattern mining helps to process the data using the AI based algorithms to get detailed insights of the data.